Hi everyone. This week we will be doing quadratic equations, a topic many of you have definitely heard of before. So we're going to go over some ways to solve these, and yeah, let's just do it. So a quadratic equation is essentially an equation in the form ax squared plus bx plus c, where a, b, and c are constants. So these are numerical constants, and x is the variable that we are trying to solve for. And the numbers a, b, and c are called coefficients. So just a little bit of insight on why this is called a quadratic equation. Quadra means square in Latin, so that's just because we have the x squared in here. So one way to solve quadratics is by factoring, or by breaking the equation down into its parts. So you know that numbers have factors, right? 6 has factors of 2 and 3 and 1, and 6 itself is also a factor. But usually that's not very useful if we're trying to actually glean information about what components make up 6. Quadratic equations can also be factored into the product of two binomials. And binomials are just expressions with a single variable and a single constant. So some examples of binomials, you'll see things like x plus 9, 7x plus 1, negative x plus 3, 4x. The constant can be 0, although you don't want the coefficient of x to be 0, because then x just equals, then you're not going to have a variable anymore. So you have to have your x in there. But you cannot have x raised to some power, right? If it is a factor of a quadratic, you're not going to have x raised to a power, because it's going to be linear. So one way to solve a quadratic equation is to find the two binomials that are its factors. So before we even begin to solve a quadratic, we have to put it in the form ax squared plus bx plus c equals 0. 0 should be on the right side. And basically, we want to turn this quadratic equation into its factored form, which is a times x minus r times x minus s. And so x minus r and x minus s are the factors. We also have a at the front. So a times x minus r times x minus s is going to be equal to ax squared minus a times r plus sx plus ars, sorry, this is supposed to say ars, is equal to ax squared plus bx plus c. So that means b over a is equal to negative r plus s, and c over a is going to equal r times s. So all we have to do is find two numbers r and s that satisfy b over a equals negative r plus s, and c over a equals rs. So I just want you guys to take 5 seconds and try to solve these two quadratics. So I'll give you 5 seconds to pause the video if you like and try to solve them. Okay, so let's start with the first one. We want to solve x squared plus 5x plus 6, right? And we want to turn it into its factored form a times x minus r times x minus s. And you'll notice that a is just equal to 1 in this case, so we don't really have to worry about this. But we want to turn it into this form. We know that a equals 1, and b equals 5, and c equals 6. And so therefore we know that 5, right, is equal to negative r plus s, and 6 is equal to rs. So negative 5 is going to equal r plus s. And we want to find two numbers rs that satisfy these two conditions. And it just so happens that we can find that if r equals negative 3 and s equals negative 2, so you can also switch these, the order doesn't really matter. You find that, of course, these two numbers do satisfy both these conditions. So looking at this thing here, we now have x minus negative 3, so x plus 3. And x minus s is going to be x plus 2. And this is our factored form. And just on why we factor it, So let's say this is equal to 0, which is what we're going to have. We always have all the numbers on one side and 0 on the other side. So to solve this, we will know that either this is equal to 0 or this is equal to 0. So if x plus 2 equals 0, that means x is equal to negative 2, right? And if x plus 3 equals 0, then x must equal negative 3. And you'll see that our two roots, that's what we call our solutions. That's just another name for solutions. Our two solutions here are exactly equal to our two roots that we have here, right? So these numbers r and s are our solutions to our quadratic. And you might be wondering, okay, well, where did I pull these numbers out of? You know, where do I randomly get out of thin air negative 3 and negative 2? I mean, they work, but it just seems like you guessed them, right? Well, yes, I actually did kind of guess them. Because in factoring, a lot of the times it does come down to guessing. And it's not really a total guess. Because if you do more quadratic equations as you factor more and more, you're going to develop a very strong intuition for what numbers are going to make up certain conditions, right? And you're going to be able to sometimes instantaneously know, for even very complicated factoring problems, which exact numbers will factor that quadratic equation just out of pure intuition. But that takes practice, so that's why you should always practice math. It's the only surefire way to get better at it. And let's also solve the other equation that we had. So 2x squared plus 4x plus 2. So here we have a is equal to 2, b equals 4, c is equal to 2. And we know that, well, b over a, right, is going to be equal to negative r plus s. And c over a is going to equal rs. And so b over a is just 4 over 2, so that's going to equal 2. And c over a is just going to equal 2 over 2, so that equals 1. And now we're ready. So we have r plus s equals negative 2, right, because we multiply both sides by negative 1. rs is equal to 1. And I think this one should be very obvious. R equals negative 1 and s equals negative 1. Solve this quadratic, right? So if we factor it, we're going to get 2 times, right, because now there's an a in front, 2 times x plus 1, because we're subtracting negative 1, remember. It's x minus r, x minus s, times x plus 1 is equal to 0. And you can see our only solution here is x equals negative 1, which applies for both. So this is our solution. So actually I already went over this, but once we've broken down the quadratic into this form, a times x minus r times x minus s, there are two possible solutions for x. X either equals r or s, because of course both binomials will either one can equal 0 and we will solve. So if we know the factored form, we have our solutions for x immediately. So s and r are both solutions. So here's just a little bit more factoring practice. So I'll give you 5 seconds to pause the video and maybe do some of these questions, and I'll explain them. Okay, so I'll do the first 3, and the last few you can figure it out on your own. Our first quadratic here is x squared plus 4x plus 3 equals 0. So immediately we see that a equals 0. A equals 1, so we don't really have to worry about it much. So we have 4 is equal to negative r plus s. 3 equals r times s, so we have negative 4, right, equals r plus s. And we can see that negative 1 and negative 3 solve this equation, because negative 3 times negative 1 is going to equal 3, and negative 1 minus 3 equals negative 4. So we factor this into x plus 1, x plus 3. And these are our solutions. In fact, we didn't even have to find the factored form here. We've already figured out our solutions right away. And our next problem is x squared plus 10x plus 25 equals 0. So we have, again, a equals 1, so we don't have to worry about it as much. But we have 10 is equal to, or negative 10, just for convenience, is equal to r plus s, right? Remember, we're just multiplying both sides by negative 1. Nothing too confusing here. And 25 equals r times s. And if you're familiar with their squares, it should be very apparent that r is equal to negative 5 and s is also equal to negative 5. So, sorry, my s kind of looks like 5 there. 5 is most definitely not equal to negative 5, that is for sure. Okay, wow, these really look like 5s, don't they? Alright, here, it's an s. Just have faith that that is not a 5, okay? So, of course, negative 5 minus 5 equals negative 10, and negative 5 times negative 5 equals 25, so we have our solutions. And we can see that x equals negative 5 is our only solution here. And if we wanted to factor it, we would get x plus 5 squared equals 0. And for our third equation, we have x squared minus 6x plus 7 is equal to negative 1. And first we realize, well, 0 is not over here. We have to get 0 on our right-hand side, right? So we're going to add 1 to both sides. So immediately going to turn that into x squared minus 6x plus 8 equals 0. And now we're ready. So we have 6 equals r plus s. Right, we negate negative 6, and we have 8 is equal to r times s. So this one, a little bit more tricky. But just play around with it for a little bit, and you'll realize that r equals 4, s equals 2. It's a very nice solution to this, since 4 times 2 is equal to 8, and 4 plus 2 equals 6. So if we just plug that in right here, we can see that our solutions are x equals 4 and x equals 2. So these are our solutions here. And if we want to turn it into factored form, of course, then we're going to have x minus 4, x minus 2. Recognize how it's minus now, right? We're always subtracting. It's just that in these cases, we were subtracting negative numbers, so they made pluses. Right? But now we're actually subtracting positive numbers. When our roots are positive, we have negatives, right? Because, of course, we need to subtract if we want to make them equal to 0. So this is our factored form here. And for the rest, you can just follow a similar procedure. Now, there's another method that we have to use called completing the square. So some quadratic equations are very, very hard to factor. Factoring is kind of a learned skill, so guessing the correct factors for the constant term to add up to the linear coefficient can be pretty difficult. And a lot of the time it's actually almost impossible because there's square roots involved. So another way to solve a quadratic equation is by the method of completing the square, and this will allow you to get pretty much any quadratic solution. So suppose we have the equation x squared minus 2x minus 48 equals 0. So you might be able to easily guess this one, but let's see how completing the square works. First, we want to bring the constant term, negative 48, to the other side, okay? So the constant term goes on the right-hand side. So now we have x squared minus 2x equals 48. Now we use the coefficient b, in this case -2, of the middle term to complete the square. So remember how x plus a squared is equal to x squared plus 2ax plus a squared? Well, in this case, 2, and I probably shouldn't be using a here because that usually means something entirely different in a quadratic, but in this case, 2ax is equal to -2x, so a equals -1. So what we want to do is add a squared to both sides of the equation, and then turn the left side into a perfect square. So here we would add 1 to both sides, getting x squared minus 2x plus 1 equals 49. So we have x minus 1 squared equals 7 squared, right? So we have x minus 1 is equal to plus or minus 7. So it could be positive or negative 7. So I just want you to think about why it's positive or negative 7. So I'll give you 5 seconds for that. So it's going to be plus or minus 7 because 7 squared and -7 squared are both equal to 49, so it really could be either of them. And x is thus equal to either -6 or 8, so that's our answers, -6 or 8. So our factored form is going to be x minus -6, which is just x plus 6, or x minus 8 equals 0. So when we complete the square, this is what we're really doing. So we have x squared plus bx plus c equals 0. And we're going to move the constant term. So we have x squared plus bx is equal to -c. So then we're going to add b over 2 squared to both sides. So now we have x squared plus bx plus b over 2 squared, which is equal to -c plus b over 2 squared, which is equal to x plus b over 2 quantity squared. And then we can just take the square root of both sides and work from there. So I'll give you 5 seconds to try completing the square on the phone. Okay, let's try to do some of these questions. So once again, I'll be doing the first 3 since the other one can also be solved using the exact same method. So let's try the quadratic that we first saw, x squared plus 5x plus 6. And we want to solve this by completing the square. So remember, we first bring the constant term onto the right-hand side, so is equal to -6, right? And now we want to turn this thing over here into a square. So we notice that b over here, b is equal to 5, right? So b over 2 is equal to 5 over 2. So if we add 5 over 2 squared to both sides, we're going to get x squared plus 5x plus 5 over 2 squared equals -6 plus 5 over 2 squared. And now we can turn this into x plus 5 over 2 quantity squared is going to be equal to -6 plus 25 over 4, right? And we can realize that -6, well, that's just equal to -24 over 4. So this just simplifies to 1 over 4. And now if we take the square root of both sides, so square root this, right? So we're going to square root both sides. We're going to get, or rather not square root both sides, but essentially just reduce. So we have x plus 5 over 2 squared, 5 over 2, sorry, is going to be equal to plus or minus 1/2, right? Because square root generally means positive, but in this case we want both the positive and negative part here. So then we can just see, well, if x plus 5 over 2 is equal to 1/2, then we just get x is equal to negative 4 over 2, which is equal to negative 2. Or we can also get x plus 5 over 2 is equal to negative 1/2. So x is equal to negative 6 over 2. 6 over 2 equals negative 3. And of course, now we have our solutions, negative 2 and negative 3. And if you want to factor this, we just have x plus 2, x plus 3. And you might be wondering, wow, this seems like such a huge hassle, right? Well, right now it does seem like it is. Partially because I've written out the entire process, which you probably won't need to do once you're experienced. And also because, well, for this one, factoring is obviously better. But for the next one, I think you'll find that factoring is not very good as a method of solving here. So x squared plus x minus 3 over 4 is equal to 0. And now it's like, whoa, how are we going to factor this, right? So instead, we're going to complete the square. So it's going to equal 3 over 4. And of course, our coefficient here, b, is equal to 1. So we're going to add negative 1. We're going to add 1/2 squared to both sides. And you'll see that we're going to get x plus 1/2 quantity squared. It's just going to equal, this is just 1/4, so this is going to equal 1. So x plus 1/2 is going to equal plus or minus 1. And we're going to get that our solutions are x is equal to, well, if 1 is positive, we're going to get 1/2. Or if if 1 is negative, if it's negative 1, then we're going to have x is equal to negative 3 over 2. So these are our solutions. So you can see it's very, very hard to guess the correct answers for this one. So factoring not so good in this case. And for our last question, we're going to have 4x squared minus 8x minus 21 equals 0. So once again, as we've done many, many times before, we will move our constant term onto the right-hand side. And now we're going to notice, wait a minute, there's a 4 here. That's very inconvenient, right? Because we've done it before with x squared coefficient being 1, but now we don't know what to do. So now the solution is to divide everything by 4. So we have x squared minus 2x equals 21 over 4. That gets rid of our problem completely. And now we can proceed as we did before. We see that b is equal to negative 2. So we're going to, b over 2 will equal negative 1. So we're going to add negative 1 squared on both sides, which of course is just equal to 1 over 2 squared as well. But just for consistency, we're going to add this, right? So then we're going to have, I'm editing that out of the video, by the way. So because negative 1 is half of negative 2, we're going to be adding negative 1 squared onto both sides. Remember, we always just add half and then squared. Half of b, we add b over 2 squared onto both sides always. And so then we're going to have, this is just going to be 1, right? So x minus 1 squared is going to be equal to 21 over 4 plus 1, which is just equals 21 over 4 plus 4 over 4, so that's just 25 over 4. And then we have x minus 1 is going to be equal to plus or minus 5 over 2, right? And if we have positive 5 over 2, it's just going to be 7 over 2. And if we have negative 5 over 2, it's just going to be negative 3 over 2, right? So these are our solutions. So hopefully you understand that. And for our last method of solving, you might be wondering if there is a general solution to all equations of the form ax squared plus bx plus c equals 0. And indeed there is. You should not use this formula too much because many quadratics in math competitions are factorable by hand, and factoring is very useful, but it's a good way to solve any quadratic equation you cannot factor easily. So let's walk through the process of proving this formula by completing the square. So let's say we have a general quadratic equation, ax squared plus bx plus c is equal to 0. First, let's divide everything by a, just to make it in our nice little completed the square form. Now, just like we always do, we shift c over a, the constant term, onto the right-hand side. And we can see that b over 2a is going to be half of b over a. So we want to add b over 2a squared to both sides. And if we do this, we can reduce this entire thing into x plus b over 2a quantity squared is going to be equal to negative 4c, right? Over 4a plus b squared over 4a squared, right? Because we're squaring 2a, and also let's just make it so that they have the same denominator actually. So this is 4ac, 4a squared. So now this is going to be equal to b squared minus 4ac over 4a squared. And if we sort of square root both sides, we're going to have x plus b over 2a is going to be equal to the square root of b squared minus 4ac over 2a plus or minus. Always remember the plus or minus. There could be either. And all we have to do now is subtract b over 2a from both sides, and we have our finished equation. X is equal to negative b plus or minus the square root of b squared minus 4ac over 4a. 2a. And this is our completed quadratic formula. So you can use this to solve any quadratic. And of course, we're going to end off the video with an example of how we use this. So let's have a little bit of an example of x squared plus x plus 1 equals 0. So if we have x squared plus x plus 1 equals 0, if you try to factor this for a while, you'll notice that it's going to be very hard, because you'll find that even though it kind of might be factorable at first, it's really not. So you might want to try using the quadratic formula here. So we want to first identify what a is. So a equals 1. We want to know what b is. B is equal to 1. C equals 1. Okay, surprisingly convenient. So we know that x is equal to negative b plus or minus square root of b squared minus 4ac. So we can plug in everything. We have negative 1 plus or minus the square root of b squared, so that's just equal to 1, right? Minus 4 times 1 times 1 all over 2 times a, so 2 times 1. So this is going to equal negative 1 plus or minus the square root of 1 minus 4 over 2. And you'll see that this is not actually factorable because you have the square root of 1 minus 4. And this is going to result in the square root of negative 3. And if you don't know about imaginary numbers, this is going to be imaginary, so it is not the kind of solution we're looking for. However, if we switch this to negative, right, if we switch this to x squared minus x plus 1, all of a sudden, however, if we switch this to minus 1, for example, then things might actually change. So let's see. Then a is 1, b is 1, c is negative 1. However, now we will have this is negative 1 instead of being 1, right? And now, instead of negative 4, this is going to be positive 4. So now we're going to have negative 1 plus or minus the square root of 5 over 2. And these are our solutions. These are what x is equal to. Alright? So you can see that with factoring, you would never have gotten this, right? But with the quadratic equation, we can solve any quadratic we like, even those with imaginary components. Thank you all for watching, and I'll see you next week.